Hi guys, in this video we're going to be looking at very much the same thing we did in the last video, which is using completion of the square as a method for solving quadratic equations if we're comfortable doing that. And so we're going to take a look at a different quadratic equation that's going to involve a few different techniques that are important to highlight, but the process is going to be very much the same. And so you notice that the only difference I'd say on this one is that I ask you to find the solutions of this equation here, 4x squared minus 4x minus 2 equals 0. And so you'll notice that this is some quadratic equation it's already been set equal to 0 here, so it looks like we're just finding the zeros of some quadratic function. So I'm going to go ahead and write that down here just so we can get it in a place where we can start operating on this. If we're going to solve this by completing the square, let's go and start with moving our constant to the other side here. And so what we get on the left here is 4x squared minus 4x. On the right hand side we just have this positive 2. Now, unlike last time, we have an a value that is not 1, okay? And see, here's the thing. When it comes to perfect square trinomials, these things that look like this, they only work when the a value is 1. And so if that's not the case, then we can't simply write our c value as half our middle term squared like we could before until we make this a 1. So the step we take is to move the constant over, but if the a value is not 1, we're going to go ahead and factor it out in front. And so no matter what, we have to factor it out. Even if it doesn't go into this b term evenly, it's got to come out. So remember that when you factor things out in front, we're really taking what were there before and dividing by the number we put out in front. It's kind of the opposite of multiplication. So 4x squared divided by 4 is just 1x squared. And negative 4x divided by 4 is just negative x here. I'm going to cap this off and go ahead and write this as equal to 2. Now here's the thing. Our a value on the inside here is 1. And that's wonderful because it means that we can go ahead and add in a number inside of these parentheses here that is half the middle term squared. And that's also wonderful because then we have a perfect square trinomial. So if we said 4x squared minus x, I tend to build in my blank in the parentheses here. It's important that we do that. But what I want you to know is this. Whatever number we put here, remember, is going to be, if we redistribute the 4, taken times 4. And so we're really adding 4 times whatever number goes in here to the left-hand side. I recommend that we write plus 4 times blank here, just to recognize that we're adding 4 times whatever we're adding to the left, also to the right. And so what do we want to put here? Now remember, because it is in this form, we can add half our middle term squared, and that would make it a perfect square trinomial. The fact here, though, is our middle term is an odd number. And so half of that is going to be a fraction. So really what we need to do is we need to make sure we take our time on this. We want c to be equal to half of our middle term squared. And I would recommend right here we're just going to put negative 1 because that's our middle term. So negative 1/2 squared means that we're going to add 1/4, and we have to do this to both sides. So I'm going to put this in a different color here, kind of make it stick out. 1/4 is going to be this number that we add to both sides here. And so now I know one thing. This is a perfect square trinomial, and because of that fact, it has to factor into a square of a binomial. Remember that if this is a perfect square trinomial, then it must factor into this form right here, x plus b halves squared, where b halves was this number we squared to get our c value in the first place. So what number did we square to get this 1/4 in the first place? It was this value right here, negative 1/2. And so that's important we put a negative 1/2 right here. So this factors into this perfect square of a binomial. Now on the right hand side, this actually simplifies pretty nicely. These 4's cancel. We get 1's in both spots. And so we get 2 plus 1, we get 3. So now, our job was to find the zeros of this function. So I'm going to put a box around this right here for now, because up until now, we haven't had a 0 on one side. We had a y on one side. And I kind of asked you to put it into this, what I'm calling vertex form now, so we could see the graph first, and then go find the zeros. In this case, I'm going to tell you, since we're finding the zeros, there's no reason to bring this 3 back over to the left-hand side, because remember, what we're going to try to do is get this squared quantity by itself, so that we could use square roots to solve this. So what I'm going to do is I'm actually going to go ahead and divide both sides of this equation by this 4. Let me scroll down a little bit here, give us some room. But when I do that, we're going to get left with just this plain x minus 1/2 on the left squared. On the right hand side, we just get this proper fraction, 3 divided by 4. Now, just like last time, we are going to go ahead and take a square root of both sides. This does highlight a very important property, and that is that if we ever take the square root of a fraction, that is the fraction of the square roots, we can split up any quotients inside of a radical as a radical of quotients. Sorry, a quotient of radicals if you have a radical of a quotient. So on the right hand side here, I'm going to write this as square root of 3 over the square root of 4, and I'm going to go ahead and highlight this now. We're taking square roots, so I'm going to write plus or minus, okay? So, oh, we're getting near the bottom. I now can add this 1/2 to the right hand side, and remember, we're going to put that in front of the plus or minus, but I get 1/2 plus or minus the square root of 3 over, and I'm going to go ahead and write 2. So now this right here, sometimes when we do, say the quadratic formula, which is what we'll look at next, it might be written over one denominator like this, 1 plus or minus square root of 3 over 2. But this is a perfectly okay form right here, as well as sticking it over this monomial divisor right here. So these are our two zeros right here. And again, I just want to highlight this. We're going to write it as two separate zeros. One of our zeros is 1/2 plus the square root of 3 over 2. And the other one is 1/2 minus the square root of 3 over 2. And so I like these as our solutions, our zeros. I am, when I put them into the calculator, going to write them as 1 minus the square root of 3 over 2 and 1 plus the square root of 3 over 2, just because a little bit easier to go with that on a calculator. So one thing I wanted to do before we verify these is sketch it right. We did want to sketch this. And so remember, I highlighted this step right here. If I were to bring that 3 back over to the left-hand side, and instead of setting this equal to 0, I kind of set this equal to, there we go, y again. We could graph this function to see where its zeros lie. And so I suppose this would be shifted right 1/2. Its vertex would be at 1/2, comma, -3. Okay? And so if this is, say, 1 right here, we're going to say here's x equals 1/2 as our axis of symmetry. X equals 1/2. And we know we got to go down 3 on this notch marks here. So there's our vertex, and this opens upward, and it's vertically stretched by a factor of 4. So, a parabola typically from its vertex goes right 1 up 1. We have to go right 1 and up 1 times 4. So that's up 4. That means that's going to place us 1 above the x-axis here on this side. And actually, I take that back, because as we go 1 to the right of this, that would mean when we're at 1.5 here, I'm 1 above the x-axis. And if I go 1 unit to the left of a positive 1/2, we'd be at about -1/2. I'd be 1 above the x-axis here. And so this would give us a pretty good idea of what our function looks like. One thing we can do, though, is we can say for certainty it's somewhere between 0 and -1. We have a 0, and between 1 and 2, we've got a 0 there also. And so what I want to do finally is let's confirm these on our calculator. If you get your calculator next to you, it's a little bit easier to type in. Let me hit clear here. These expressions, because what I can do is I can hit in parentheses 1 plus the square root of 3, which right here, square root of 3, I need 2 in parentheses on that. 1 for the square root, 1 for the numerator, and I'm going to hit divided by 2. In both instances, we have to divide by 2. So if I hit second enter, and I don't have to type all this in again, but I go back and I change this plus to a minus, and divides it by 2 again. We get these two zeros right here. That means that we have -0.37 is this 0 on the left, and 1.37 is this 0 on the right. And so I'm going to say 1.37 and about -0.37-ish. We use approximately equals on both of these, but this is what we have. And so as far as min and max go, we can just look at our vertex this time, but looking at the picture, it does help to identify that this is a minimum. But we could say we have a min of -3. Cool? Cool.